Gauss-Seidel method. This is one of the iterative method. We call this method as iterative method. Iterative method is nothing but doing the steps repeatedly. So this is like a numerical method to find out the root of a system of linear equations. So here we get approximate value of the root, approximate value of the solution of the system of equations. Now let us take an example directly, and we will take the solution part. In this method, 3 equations will be given. First step, what you have to do is, you have to check whether the system of equations are diagonally dominant. Diagonally dominant. What do you mean by this? Look at the first equation. First principal diagonal element is 20. 20 mod 20 should be greater than coefficient of y is 1 and plus coefficient of z is minus 2. So this 20 is greater than 3. This is diagonally dominant. Similarly, look at the second equation. In this, the principal diagonal element is 20, coefficient of y. This should be greater than the other elements of, coefficients of x, that is 3, and coefficient of z is minus 1. Means 20 is greater than 4. This is also true. The third equation, look at the principal diagonal element. This is 20. Again this 20 should be greater than coefficients of x and y. This is 2 plus mod minus 3. This 20 is greater than 5. This is also true. See, this is in the first equation, second and third. Third equation, diagonal elements were taken. This is coefficient of xy. This is coefficient of x and z. This is coefficient of x and y. So if this is true, then we say that the system is diagonally dominant. Okay, so first you have to check for this. If it is diagonally dominant, you have to proceed. Then in the next step, we have to start with the initial solution. Assume initial solution for x, y, z. X equal to 0, y is equal to 0, and z equal to 0. These are the default values. For all the problems, you have to take in the same way. After this, you have to rewrite the equations in this form. X is equal to, look at the first equation. First equation, here you have to separate x. 20x is equal to 17 minus y plus 2z. This implies x is equal to 1 by 20 into 17 minus y plus 2z. From the second equation, you have to separate y. 20y is equal to minus 18 minus 3x plus z. This implies y is equal to 1 by 20 minus 18 minus. Now third equation, separate z. 25 minus 2x plus 3y plus z is equal to 1 by 20. 1 by 20 to 25 minus 2x plus 3y. Okay, so for all the problems you have to follow the same procedure. Once it is diagonally dominant, then you have to write the equation in this form. First equation separate x, second equation separate y, and third equation separate z. Then after that, first iteration. In this, since we have taken the default values as 0, x0, y0, z0, so in the first iteration we write like this. x1 means first iteration. So 1 by 20 into 17 minus y value 0, z value 0. So we get 17 by 20. This gives us 0.85. Similarly, y1, first iteration, 1 by 20 minus 18 minus 3 into x1 value you have to use here. x1 is 0.85, previous value not 0, plus z is 0. So if you simplify this, we get minus 1.0275. Similarly, first approximation z1, 1 by 20 25 minus 2 into x. X means previous term. This value you have to use 0.85 plus 3 into y, the previous y value 1.0275. So if you simplify this, we get 1.0109. This is first approximation. Next we take the second approximation. Second approximation or second iteration. Both the ways you can call it. Second iteration, here x2 is equal to 1 by 20 into, look at these equations 1, 2 and 3. Always you have to refer these two equations to substitute here. So 1 by 20 into 17 minus y. Y means previous y value, is minus 1.0275 plus 2z. 2 into z. Z is this previous value 1.0109. Now if you simplify this, we get 1.0025. Similarly, y2 is 1 by 20. Look at this equation, y2. This equation is 1 by 20 into 18 minus 3x. 18 minus 3 into x. X means this value you have to use 1.0025 plus 2z. 2 into z. Z means this value. So 1.0109. Now if you simplify this, we get minus 0.9998. See here in numerical method you have to take 4 decimals. After a digit, after decimal point, you have to take 4 digits, and the fourth digit you have to round off. Round off means suppose if it is greater than 5, suppose for example 1.7 is there, 1.7894 is there means 948 is there means then you have to write it as 1.7895. This is rounding off to the next integer, means we are writing it as 5. Okay, if it is greater than 5, then we increase this 4 as 5, is called as round off. Okay, similarly z2 is 1/20 into 25 minus 2 into x, 1.0025. This x value, previous x value have to use, plus 3 into y value minus 0.9998 is equal to z2 0.99988. This is second iteration. Next we take third iteration. Okay, you may have a question in mind, where do we stop or how many iterations we have to take. So you have to look at these values. First iteration we got 0.85 for x. Next iteration we got 1.0, means the difference is the difference is less, like 0.85, 1.025. Next iteration, if we get the difference less, the difference between the consecutive values of x and y and z, if we get very less or very close, they are very close to each other, then we stop the process. Okay, let us take this, then we will get a clear idea. So x3, third iteration, 1/20. Similarly, you have to substitute 17 minus here the previous y value and z value. Previous y value is minus 0.9998 plus 2 into z, 0.9998. Now if you simplify this, we get 0.999999 you will get y nines, so you can approximate it to 1 directly. Then y3 is 1/20 into, substitute the values, 18 minus 3 into 0. Previous x value 0. Have to look at this equation y. This equation, there you have to substitute x.997 will be there. So we have approximated to 1. So directly you can take this as 0.9998. So this will give us minus 1. So you will get minus 1.000005. So that is minus 1. So directly we can write that. Then z3 equal to 1/20 into 25 minus 2 into 1 plus 3 into minus 1. So this you will get 1.000002. So that is approximated as 1. See, here you will get 1.000 something 0002 like that. So this is approximated as 1. Okay, therefore the solution of, we stop the process. You can see here 1.0025 and here it is 1. The difference is very less, and y, the second iteration y value is 0.998 and here it is minus 1. Z value is 0.99998, here 0.00. That means the difference is very close. Therefore we stop the process and we say that x value, approximate value of the x is 1, approximate y value is minus 1, approximate z value is 1. So this is the solution of given system of equations by using Gauss-Seidel method. solve this question yourself. Here you have to check whether this is diagonally dominant. Look at the first element. 10 is greater than 1 plus 1. Means 10 is greater than 2. So first equation is diagonally dominant. Second equation, look at the second diagonal element. This is 10. This is greater than 1. Quotient of x is 1 plus quotient of z is 1. This is diagonally dominant. Similarly, third equation, third diagonal element is 10. This is greater than 1 plus 1. This is diagonally dominant. Then you have to assume x equal to 0, y equal to 0 and z equal to 0, and separate x from this, y from this and z from this, and follow the same procedure. You will get at the end of the third iteration, you will get x is equal to 1, y is equal to 1, z is equal to 1. This is approximate value. That means you will get 0.99996 like that. So that is approximated to 1, 1, 1. Okay, you may not get 1 exactly. You may get x equal to 0.99965 like this. This is approximated to 1. Similarly, y and z. That you have to check. Now look at the next question. Here you have to check whether it is diagonally dominant. Here 5, first diagonal element is 5, 5 is greater than 2 plus 1, 3. Second diagonal element is 4, 4 is greater than 1 plus 2, 3. Third diagonal element 5 is greater than 1 plus 2, 3. So it is diagonally dominant. Diagonally dominant. Okay, so then you have to express from this equation separate x, separate y, and from this separate z. And here in the question it is given that 103 as the initial approximation. So here you have to take x equal to 0, y is equal to x equal to 1, y is equal to 0, z equal to 3 as initial approximation. Initial approximation. Okay, see, in the previous problem we used to take default values as 0, 0, but here it is given 103. That you have to take, and you have to carry out 4 iterations. That means you need to find x4, y4 and z4. So whatever the value you will get at this stage, that you have to write as the solution of the given system of equations. For this question you will get the answer x, y, z is this, that you can verify. Then see the fourth question, solve by Gauss-Seidel method. 3 equations are given. First you have to check whether it is diagonally dominant. Here first diagonal element is 1. 1 is it greater than this? 1 plus 54. This is modulus of 54. This is not true. It is not greater than. Similarly, second diagonal element is 6. 6 is not greater than 27 plus minus 1 means 28. 6 is not greater than 28. This is also not diagonally dominant. Similarly, 2. Third diagonal element is this. 2 is greater than 6 plus 15. This is also not true. So that means this system is not diagonally dominant. In that case, what we have to do is, you observe carefully. Here we have 27. Okay, and here we have 15. 15 is greater than 6 plus 2. 27 is greater than 6 and 1. And here 54 is there. So now we will take this as equation 1 and this as equation 2, and this as equation 3, so that the system becomes diagonally dominant. So you can look at this 27x, rewrite the equation 6y minus z is equal to 85. Second is 6x plus 15y plus 2z is equal to 72, and then x plus y plus 54z is equal to 110. Now 27 is greater than this, diagonal dominant. 15 is greater than 6 and 2 diagonal dominant. 54 is greater than this. System is in diagonally dominant form. Now separate x from this, y from this, and z from this. Now initial approximation is not mentioned in the question, so assume take x equal to 0, y is equal to 0, and z is equal to 0. So to solve in that way, you will get the approximate value. At the fourth iteration, you will get the approximation value. This will be 2.4255. Then x5. You take up to 4 decimal points, approximate up to 4 decimal points, so you will get 3.5730, and y4 is 1.925, 5160, you will get 60. So this is the solution. So finally conclude that 2.4255. Why you have to take up to, you have to take this up to x4, because x4 and x3 the values will be very close, and y4 and y3 values will be very close. That's why you have to take up to x4. Generally, if it is not mentioned, see that the answer you will get at third iteration or fourth iteration in general. So 1.9260. So this is the conclusion. Hope all of you understood. Thank you for watching this video.